Imagine that the end of the world doesn't begin with a massive explosion, not with a giant asteroid ripping through the sky, not even with a nuclear weapon detonated by human hands. Imagine there is no warning, no countdown, no dramatic final message. Imagine instead that everything begins with something incredibly small, something so insignificant that you would never look at it twice. A sewing needle. A thin piece of steel weighing less than a gram. A quiet tool we use to mend clothes, to stitch torn fabric, to fix something broken with patience and care. It sits forgotten in drawers and sewing kits, associated with calm, precision, and harmless human work. Nothing about it suggests danger. Nothing about it feels powerful. But the universe does not measure danger by size. It does not care about intention. It does not distinguish between a tool made to repair and a force capable of destruction. In physics, there is only one thing that truly matters: motion. And when motion changes, everything changes with it. So ask yourself this question, and don't answer it too quickly. What if this needle were launched from space, aimed directly at Earth, not at the speed of a bullet, not at the speed of a rocket, but at the speed of light? At the moment that happens, this stops being imagination. It stops being theory. It becomes a catastrophe already in motion. To understand why, we must abandon intuition. Human intuition evolved to understand falling rocks and thrown spears, not objects moving at relativistic speeds. At these extremes, common sense collapses. Only energy remains. Normally, when something enters Earth's atmosphere, it heats up due to friction. Air molecules collide with it, energy transfers into heat, and the object begins to glow, fragment, and often burn away completely. This is why most meteors vanish harmlessly, leaving behind nothing but a brief streak of light. But this scenario is not normal, not even close. At near light speed, friction is no longer the right concept. The physics changes entirely. What we are dealing with now is relativistic kinetic energy. Energy so extreme that it begins to tear apart the structure of matter itself. According to Einstein's theory of special relativity, as an object approaches the speed of light, its energy increases dramatically. Time slows, length contracts, and the energy required to push it faster grows toward infinity. If an object with mass reached 100% of the speed of light, its energy would become infinite, implying total destruction of space-time itself. That is why such a thing cannot exist. So instead, let us imagine something just barely below that limit. 99.9% of the speed of light. At this speed, the needle is no longer a simple object. Its kinetic energy is so immense that it effectively becomes a concentrated weapon, carrying energy comparable to the most powerful nuclear explosions ever created. The needle reaches the atmosphere. Air molecules do not move aside. They do not compress or flow. They do not have time. The needle collides head-on with nitrogen and oxygen atoms, shattering atomic nuclei, stripping electrons, and releasing violent bursts of energy. What forms ahead of it is not fire, but plasma, a superheated, radioactive state of matter hotter than the surface of the sun. You would not see the needle fall. You would see a blinding, impossibly thin column of light connecting space to Earth, appearing and disappearing in less than a microsecond. Then comes the impact. The needle strikes the planet at such speed that solidity becomes meaningless. Rock behaves like liquid. Steel behaves like vapor. The needle does not stop at the surface. It punches deep into the Earth's crust before releasing its energy in a single instant. The explosion would rival the Tsar Bomba, the most powerful nuclear weapon ever detonated, but compressed into a point no larger than the tip of the needle. Everything within several kilometers is instantly vaporized. Not burned, not shattered, vaporized. In the seconds that follow, a thermal shockwave melts sand into glass, ignites forests, and devastates cities hundreds of kilometers away. If the needle struck the ocean, millions of tons of water would vaporize instantly. Massive tsunamis would race across entire ocean basins. Water vapor and debris would rise into the atmosphere, blocking sunlight, cooling the planet and destabilizing global climate. All of this caused by an object smaller than your finger. It sounds like science fiction. It feels unreal. But the physics behind it is unforgiving. And yet, there is relief hidden in this nightmare. Because the same laws of physics that allow us to imagine this scenario are the laws that prevent it from ever happening. In our universe, nothing with mass can reach the speed of light. The faster you push, the harder reality resists. Infinite energy is required, and infinite energy does not exist. The fastest object ever built by humans reached less than 1% of the speed of light. We are unimaginably far from creating a weapon like this. The universe is violent, but it is also disciplined. The laws of physics are the invisible walls that prevent absolute chaos. So that tiny sewing needle will remain exactly what it has always been. A quiet tool for careful hands, resting safely in its box, repairing fabric instead of tearing worlds apart. At least, in this universe.